All right, the last section of Chapter 13 deals with pyramid models. We're going to be looking at how energy transfers through ecosystems. You're going to definitely want to pay close attention to this section. This one is a major deal. So let's start off with main idea. Energy pyramids show the distribution of energy among trophic levels. In other words, energy pyramids, which is in the shape of a pyramid, show how energy is passed along or decreases as we move from the bottom to the top trophic level. Think about a food chain. They all start with an autotroph, plant of some sort. Then they move up to an herbivore because the herbivore eats the autotroph. And then they move up to a different heterotroph, maybe a carnivore or a top-level predator. There's way more energy in all of the grass that the cow ate. Cows are herbivores and they eat autotrophs, they eat grass. So there's way more energy in that grass than the cow. Why doesn't the cow get all of the energy from the autotroph? Because they have to use energy as well. They have to go through metabolism, so do autotrophs. As a result of metabolism, energy is lost as heat, and that heat goes to the environment. Well, same thing as moving up from this trophic level to this one. These guys have to undergo metabolism, so do these guys, so some of the energy is lost to the environment as heat. And this makes sense if you think about it. When you are active, just like these guys, your metabolism increases. So think about it like this. You normally walk, but you have to trot to catch the bus one day. What happens? Well, what's going to happen is you're going to sweat a little bit. In other words, your body is giving off heat. Where does that heat go? It goes up into the atmosphere. So it's lost as heat. And if someone were to come along and eat you, they would get less energy from you as a result, because some of that energy was lost as heat. So let's check that out in a food chain. Here we see a food chain. We have, looks like 1, 2, 3, 4, 5 trophic levels. So how many trophic levels are there in this image? There's 5. And it starts with a producer. What's another name for a producer? An autotroph. So the plant, it goes through photosynthesis. It's a producer. It can make its own food. Can grasshoppers make their own food? Nope. They're going to be eating the plants. Because grasshoppers eat the plants, grasshoppers are heterotrophs, also known as consumers. Birds eat grasshoppers, so birds are also consumers. Birds would therefore also be a predator. But they're not the top predator because birds are eaten by something else, like snakes. Snakes eat birds, so snakes are also heterotrophs. They're a predator of the birds. And then we have the owls at the top of the food chain who eat snakes. Therefore, owls are also heterotrophs or consumers because they are eating other animals. Now, is there anything that eats an owl? No, not really. So owls are said to be top-level predators, which we'll come to know as tertiary consumers. So which organisms are autotrophs, which are heterotrophs? List those out. And also, looking at this, we can start to see how plants get eaten by these guys, so on and so forth. And I want you to know that all of the energy that's in this plant, if the grasshopper were to eat this entire plant, the grasshopper is not going to get all of that energy because some of it has been lost as heat. The bird that eats this grasshopper, is the bird going to get all of the energy in this grasshopper? Nope, because some of that energy is lost as heat. What about the snakes? All the energy from the bird? Nope, because some of it's lost as heat, and same with the owl. So, putting our discussion into words, loss of energy, organisms require energy. We require energy. The use of that energy is metabolism. one of the byproducts of metabolism? Heat. So, as a result of the loss of that heat, the energy decreases as we move up the trophic levels. There's less available. Why? Because organisms use some of the energy that they have, and therefore they cannot pass that energy to the next trophic level. And finally, here is a picture of an energy pyramid. These percents measure the amount of energy that these guys get. So, bamboo is a plant. It's a producer. This bamboo has a lot of energy. All of the energy in this bamboo does not get passed to the panda. The panda could eat all of this bamboo, but the panda, in the long run, it's only going to be able to retain 10% of the energy it gained from eating all of that bamboo. And the jaguar, who eats the panda, is only going to get 1% of all the energy the panda has. So we see a trend going on here. We are losing a lot of energy as we move up the energy pyramid. The jaguar needs to eat a little bit more to get energy. So, that concludes chapter 13.6. This is one that I do want to review with you as we come together as a class again.